Hey you guys, it's Mr. Sal. I'm gone for the day, so this is just a sub-lesson plan. It's just a video. I'm going to give you guys a chance to do each of the problems, and you'll have some time to do those. And then when you see the answers, you'll have about 30 to 45 seconds to see the answers. I'll do some explaining as well. But for the most part, you'll be on your own, so if you have questions, you'll have to hold them, or you have to find someone in the class who can help you. So if the video is going too fast, just have the sub rewind it, all right? And with that in mind, go ahead and take a moment to do the bell work. And we'll show you guys the answers as well to all of the homework problems. You'll score them based on the video. However, I won't be able to take scores because, well, I'm not there. So we'll take scores when I get back. All right, here's the first slide. Now that says Unit 6, but it should be Unit 5. So just keep that in mind when you're correcting this. Doesn't matter what it says. It's still the same assignment. The answers are the same. It's 1 point per part. So one there has 2 parts, one for each unit rate. So this has 10 points on it. And this is the second page. You'll have some time to correct this one as well. If you don't get it all, even though you should, you may get some time when I get back. I don't know yet. But correct it, please, and score your work. Of course, at the bottom you can see all the scores. So score it, but naturally the sub can't take your scores. So. All right, in this problem, we're going to see that we have a recipe that makes 24 cookies, and it calls for 4 cups of flour. What is the unit rate of cups of flour per cookie? So the unit rate specifically that we're looking for is the per cookie unit rate. So as of now, this is our ratio, 24 cookies to 4 cups. And I'm going to do this a different way as well. All I'm going to do is have this fraction reciprocated. Now the reason I'm doing this is because, and we talked about this in class, is that it doesn't matter if I have the cookies in the numerator as I do on this fraction or in the denominator like this one. But what we want out of both of these is to know how many cups per 1 cookie. So again, I've reestablished both of these as unit rates, except for both of these we've got to figure out how many cups we need. So in both situations, what we're going to have to do to get that 24 cookies to 1 cookie, we will have to divide the 24 by 24. Notice this is not anything new based on what we've already been doing. And since we divided the 24 by 4, we'll also have to divide the 4 by 4 as well. Now again, these are the same rates. It just depends on if you have the cookies in the numerator and denominator. And yes, I apologize, I wrote that down wrong, so I corrected. It's 4 divided by 24 there. And 4 24ths can be simplified, so that's what I'm going to do now. And we see that both of these give us a proportional ratio of 1/6 cup to 1 cookie, or 1 cookie to 1/6 cup. Now that we have that, and I've written it right there, 1/6 cup of flour per cookie, how many cups of flour would be used for 20 cookies then? So simply I write this as a unit rate, which you can see right here. And if I wanted 20 cookies, I would just multiply 1 cookie by 20 to get the 20 cookies, but I've also got to multiply the 1/6 by 20 as well. So what I have is 26 cups of flour for 20 cookies, but that can be simplified as well. And we see here now that we have 10/3 cups of flour for 20 cookies, and that right there is our actual final answer there. Alright, from here we want to know how many cookies we can get for each cup of flour, 1 cup of flour. So if we look back at our unit rate that we have, which was cups of flour per cookie, then we know if we reciprocate the cups, then we will know how many cookies it is. Or in other words, since we want 1 cup right here, we would multiply that 1/6 by 6, or 6 over 1. So we'll multiply the cookies by 6 over 1 as well. So in other words, we've reciprocated that 1/6 to get the 6 cookies out of 1 cup of flour. So this one right here is 6 cookies. So then, how many cookies could be made with 5 cups of flour? Let's go ahead and write that ratio. So I have it now, the cookies are in our numerator and cups in the denominator. Again, it doesn't matter where those are as long as the cups and the cookies, after we've written our initial ratio, as long as we have those written either in the numerator and denominator consistently, that's fine. So how do we get from 1 cups to 5 cups? We take that 1 cup and multiply it by 5, and we'll take the 6 and multiply it by 5 as well. So we see out of 5 cups of flour we can get 30 cookies. And how many cookies could be made with 0 cups of flour? Well, at that point you're going to have 0 cookies. So we need to find a unit rate from this information. Then we'll use the unit rate to answer the additional questions. You may use models if you choose, but they are not required. This table shows the number of inches of snowfall for each hour. What is the unit rate of hours per inch? See if you can figure that out. And do B, C, and D as well. Okay, I'll give you guys some time to do those. But go ahead and see if you can solve those, and we'll do them together at the end of some time here. So the hours per inch, so we were looking for 1 inch, which it gave us in the table right here. That's 1 inch right there for 1/2 hour. But let's say that there's 7.5 inches of snow. How long has it been snowing? So there's a couple ways we can look at this. We can compare our unit rate, and then we can determine how many hours using a proportion like this it will take to snow 15/2 inches. So the nice thing about this is using the unit rate, we simply multiply that 1 inch by 15/2 in order to get the 15/2 there. But we'll do it as well to 1/2 hour, so 15/2 like this times that 1/2 hour. And we'll just multiply the numerators together, getting 15. And the denominators, 2 times 2 is 4. So in order to snow 7.5 inches, it will take 15/4 of an hour. And what is the unit rate of inches per 1 hour? Well, that gave us the problem added for us right here. 1 hour would produce 2 inches. Then how many inches of snow would have fallen in 2 1/3 hours? 2 1/3, I'm going to change that into an improper fraction. And I get 7/3 hours. And so I've reestablished a working proportion. And I know if I multiply the 1 by 7/3 that I'll get the number that I want. But I've got to do it to the 2 inches as well. And that would give me 14/3 like this. So in 2 1/3 hours, we would expect 14/3 of an inch. And there we go. Alright, this table shows the cost of a plumber for the amount of hours worked. What is different about this table? And also do B and C as well. So it has a value of $45 for 0 hours, which is different than all of the context that we've been looking at in this unit. We can see that they are going to charge $45 for 0 hours. So just come out and check and take up their time. They have to charge you an hourly rate or some type of rate so that they're not losing money in that case. So to answer, part B, is there a unit rate or proportional constant? And we'll justify our answer as well. But we just need to compare these as fractions. So let's compare these two, for example. So I've written $70 per hour as a ratio. And in order for them to be proportional, they need to be equal. So in order for there to be a proportional constant, we first can figure out if it's proportional by comparing these two values. And so we can look at these, and if it's necessary, we can simplify this 95 halves into some decimal value, but whatever it is, it looks like it'd be about 45 and a half, which is not $70 for 1 hour. So in other words, I would divide both these by 2, and then I would see if that would equal the $70, which it does not. So the answer is no, this has no proportional constant because the fractions, the ratios as fractions, or rates, or whatever you want to call it, they are not equivalent. Therefore, they are not proportional. Now, is the relationship between hours work and cost proportional? Well, no, because we've already figured out, based on what we just did, that it is not proportional. At least these two values right here, they would not produce equivalent ratios, and therefore they are not proportional. All right, this problem has parts A, B, and C. So I'll take a moment and solve those three, and fill in the table. Again, you're going to want to use maybe unit rates or just some equivalent fractions in order to figure out those missing values. So here we go. We've got triangle A with 4 and triangle B with 5. And it told us they are proportional, so whatever we do, we can write equivalent fractions for these. Now I'm going to solve this problem not using the unit rates. So pay attention if you want to see how this is done. But there's a couple ways that we can do it. Here's the first way. So I've written 5b over 4a. That's just to establish that my triangle B values will be in the numerators and my triangle A values will be the denominators. And since they're proportional, it'll give us an equal fraction, but triangle A now has a value of 3 and triangle B has the unknown value, like this. Now it seems like we talked about this a little bit in one of the classes, but what we can do from here is use what is called cross multiplication. And we don't know what that value of b is, so I'm going to use the x value. And if I cross multiply these two, okay, because they are cross from each other or diagonal, then I have 5 times 3, which is 15. And this would equal, at the same time, 4 times the x, like this. Now to solve for x, in this case, I would simply divide both sides by 4. And I would see that x is 15/4, which I could put into the table like this. Now there's the value for triangle A when triangle B is 6 1/4, but let me go ahead and just set this up again. And I'm going to do cross multiplication again, and so I'll use some of the other techniques a little bit later. And so I have an x value an unknown value, which I'm going to use x, and then I'll use cross multiplication. So 5 times the x needs to equal 4 times 25/4, which would just be 25 in this case. So I have 5x equals 25, and dividing both sides by 5 gives me x equals the 5, which we have right here. Now we'll figure out the unit rate for side lengths of triangle B to triangle A. So we have triangle B with 5 and triangle A with 4. That's our first ratio, which I have written here. And we want to compare this to the unit rate. So triangle A would be 1. All right, so if it ever asks a question like this, it wants the second value to be the 1 in the units. So to do that, we would divide both of these by 4, and we would get 5/4 for the B. So 5/4 to 1 would be our ratio of side lengths of triangle B to triangle A. All right, go ahead and solve 5A and B. You'll have a couple minutes to do both of these, and then we'll go over them. So notice on 7A we have 7 miles per hour. And how did we get that? Well, we wanted 1 hour, so we would multiply 1/4 of an hour by 4. And if we multiply 1 3/4 by 4, really what it would be is 7/4 times 4 over 1. And some of you guys would cross simplify right here, giving us the 7 miles per hour. But how many miles can Arturo run in 3 hours? So if he runs 7 miles every hour, and he runs for 3 hours, it would be 3 times that 7. And you can see that Arturo would run 21 miles in 3 hours. All right, do 6A and B, and I'm going to show the answers after a couple minutes. But try these out, and then just check your answers to see how you did. All right, there were 7 inches of rain in 24 hours. If the rain continues to fall at the same rate, how many inches of rain will have fallen in 30 hours? Go ahead and try this one, and then we'll go over it together. Now the unit rate may have been helpful for you, but in this case I'm not going to use the unit rate. I'm going to use that cross multiplication stuff in order to solve this problem. So let's go ahead and start with the initial ratio that it gave us, which was 7 inches in 24 hours. So this is how I have it. And we're going to compare this to 30 hours, and it will be an equal fraction as well. So we need to figure out how many inches of rain would have fallen in 30 hours. And again, I'm going to use x as my unknown, and that is what we will solve for using cross multiplication. So I've got 7 times the 30, which would be the value on the left, and this will equal 24 times x on the right. And that 7 times 30 gives me 210 equals 24x. And we'll divide both sides by 24. And it looks like that would give us 35/4. And that 35/4 is what we would really write, and not that decimal. And it's not 34, but 35/4 inches after 30 hours. Remember, no decimals in this unit, so stay away from those. All right, the times for 3 runners in 3 different races are given in this table. Find the unit rate of kilometers per hour for each runner. We'll give you guys a couple minutes to do this one as well. All right, go ahead and do number 9. CD Express offers 4 CDs for $60. Music Place charges $75 for 6 CDs. Which store offers the better deal? Make sure to justify your answer as well. All right, try out number 10 also. Tia's painting her house. She paints 34 and a half square feet in 3/4 of an hour. At this rate, how many square feet can she paint each hour? One thing you're going to want to do on this problem is to change that 34 and a half square feet into an improper fraction, which if you do, would give you 69 and a half square feet. So see if that helps you out in solving these problems. Go ahead and give those a try. Alright, on this problem we're going to fill in the table, and then we will also graph what we find from the table, and it's all based on the flowers you see here on the bottom. So based on what you see there, go ahead and figure out the rest of that table, and the value that we know is also filled in. 2 sunflowers to 6 roses, and you'll have to use that numbers in order to find the rest of those unknown values. Alright, so here we go. We can see if we wanted to cut these in half, then I would have this one yellow flower, and we would have, oh, I guess that's one way we looked at it, right, was if you have one group of yellows, then you'd have 3 groups of reds, and that's how that will work here. Or you just could look at these numbers and cut those in half as well. So now that we know how many roses for every one sunflower, the rest of these should be pretty simple to find. If we had 3 sunflowers, we would multiply the 1 by 3, and so we'd multiply the 3 by 3 as well, and would get 9. Now what we'll need to do to find out how many roses for 4 sunflowers is to multiply the 1 by 4, and so we'll multiply the 3 by 4 as well, giving us 12 roses. And finally, if we have 15 roses, how many sunflowers? Well, to do this one, we would multiply the 3 by 5, so we'd multiply the 1 by 5 as well, giving us 5 sunflowers. And that completes the table. So now that we have those values on your paper, go ahead and graph all of those values. So from this point, we're just looking at each of these as ordered pairs. For example, this one right here would be 0, 0, which would give us a point right there. 1, 3. Now remember, these are our x's and these are y's, which are described on the graph as well. And continuing this pattern, 2 sunflowers would give us 6 roses, 3, 9, and 4, 12. And at that point, it goes off the graph. Now, we wouldn't connect these points because you can't have half a rose or half a sunflower. So what does the point 412 represent in this situation? To figure that out, what we need to do is to look at both of these. 4 is the x and 12 is the y. And then we just got to look at what they represent. Well, the x's were sunflowers and the y's were roses. So it would give us 4 sunflowers and 12 roses. Now write the ordered pair that represents 9 roses and 3 sunflowers. And once again, we see that sunflowers are our x's, which are the first value here, and 9 is the roses, which is the y value right here. One thing that may be helpful for you guys is these ordered pairs are in alphabetical order, and the x's always come before the y's. Also, I guess they did give us the ordered pair right here, so some of you may have noticed that also. Which point represents 8 flowers? Well, it's talking about both sunflowers and roses in that, so keep that in mind as you look for the answer to this problem. And there we have it. The 0.26 would give us 8 total flowers. So 2 sunflowers and 6 roses would be 8 flowers. All right, try and solve E. If you have 100 sunflowers, how many roses should you have to keep the same ratio or to keep them proportional? Also wants the answer as an ordered pair. Shelley made a bouquet with 8 roses and 4 sunflowers. is Shelley's bouquet in the same ratio? Or in other words, is it proportional? And we see the answer here, but another way to look at this is for 4 sunflowers, for the first part there, we can see that we would need 12 roses, which this one does not have. So they would not be equivalent fractions or ratios or rates. All right, look at the flower problem again, but this time put the roses on the x-axis and the sunflowers on the y-axis. In other words, just notice on this graph that the roses and sunflowers have changed where they were. So now the roses are the x's and the sunflowers the y's. But all the ratios should pretty much be the same, just reciprocated. All right, now that we have that, we can determine what the point 12.4 represents in this situation. And which point represents a total of 20 flowers? And we can see that it would be the next point on this graph, which would be somewhere over here, which would also be 15 roses and 5 sunflowers. None of these 5 points on the graph would work because none of them produce 20 flowers. If you have 45 roses, how many sunflowers should you have to keep the same ratio? We'll go ahead and solve this one. So this is the way that I have it set up. And you could use scale factors, which is what we've been doing, where you'd multiply the 3 by 15. But I'm going to use the cross multiplication just because I can, and so you guys can see how to use it. And then you can determine which of the two you like better. So 1 times the 45 is 45 equals the 3 times the x. Solving this would divide both of these by 3. And we get x is 15. So you would need 15, specifically you would need 15 sunflowers. And that would maintain the ratio of 3 roses for every 1 sunflower. Alright, you have this on your paper. It's very important. In a proportional relationship, the unit rate shows the amount of y that corresponds to 1 unit of x. We can also think of this as the amount of increase in y as x increases by 1 unit, which is a unit rate, where one of the quantities is 1, of course. On a graph, the unit rate is illustrated in the point 1r, where r is the unit rate. R, of course, would be some value instead of a letter. The unit rate can also be determined by finding the quotient yx. In a proportional relationship, yx is constant. It is also called the constant of proportionality or proportional constant. That may not have made sense, and it doesn't really have to yet. So if a recipe calls for 1/2 cup of lemon juice for each cup of water, complete the table and plot the pairs of values on the coordinate plane. Take a moment and try to do that. Complete the table and fill out the graph. Alright, let's go ahead and take a look. So, we know for each cup of water, that's 1 cup right there, it would take 1/2 cup of lemon juice, right? So if we had 2 of those, you would have 1 cup of lemon juice. Naturally, for 0 cups of water, you would have 0 cups of lemon juice. Now if you had 3 of those 1/2 cups, you would have 3 halves cups of lemon juice, and 4 of those would be 4/2, which also would be 2 cups. So if we add 15 cups of lemon juice, notice we can look at this value right here. So if we multiply that by 15, we'd multiply the 2 by 15 as well, giving us 30 cups of water for 15 cups of lemon juice. Next, we need to graph this, and we can see each of these are simply ordered pairs, so I'm going to go ahead and graph the first few here. The first one we have is 0, 0. The next is 1 and 1/2, which would be that point right here. For 2 cups of water, we have 1 cup of lemon juice, and this pattern just continues throughout, as you can see right here. And the next thing I'd want to do is connect all these points, because you can have 1/2 cup of water and 1/2 cup of lemon juice. In other words, between each of these points are other values which could exist based on this problem. And we should get something that looks like this. Now the book showed it like this, but we haven't talked about it quite yet, and we'll get into it later, but for now, maybe it makes sense for some of you guys. Part A, what does the point 42 represent in this situation? Go and write that down. And there's your answer. If I use 100 cups of water, how many cups of lemon juice should I use to keep the same ratio? Go ahead and write your answer on this one as well. And there's your answer, 50 cups of lemon juice. They didn't label that, but they did write it as an ordered pair. If I've used 60 cups of liquid, how many cups of each water and lemon juice did I use? Write your answer as an ordered pair. See if you can solve this one. And there's your answer. Of course, combining both of those, you would get the 60 cups of liquid. All right, this person mixed 2 cups of lemon juice and 3 cups of water. Did this person follow the recipe? Explain on your paper. And there's the answer. What is the unit rate? Cups of lemon juice to cups of water. And where do you see the unit rate on the table and graph? Well, you guys should notice that by now for 1 cup of water, you had a half cup of lemon juice. And you would go to the 1 on the water and find out where the point is. It used to be right here. I don't know what happened to my graph, but that's where the point would be. All right, this table shows the ratio of lemon juice to water for a new recipe. The graph shows the ratio of lemon juice to water used in the problem above. Plot the points in the table on the same coordinate plane using a different color. And you should have something that looks like that. You can see the ordered pairs as they were graphed: 3, 2, 6, 4, and 9, 6 at least, and 0, 0. That would give you that red line. Are the recipes the same? And the answer to this one is no. How do we know? Because they are not the same line. Next, find the unit rate of each of the recipes. Aria is using 5 cups of lemon juice. How many cups of water should she use for each recipe? And explain how you got your answers. All right, on to number 7. It costs $2 for 5 oranges. Complete the table and graph to represent this situation. All right, take a moment to do that. What is the unit rate? Show on the table and graph where you see the unit rate. Now, if you buy 8 oranges, how much will you spend? And we can see that value, $3.20, which also was on the graph right account. Owen paid $2.45 for 7 oranges. Did he pay more or less? Explain and use your graph to support your explanation. And we can see from this problem that Owen, if we plot the point on the graph, 7 and 245, it looks like that would be somewhere in this area, which is below that line, and therefore we know that Owen paid less.